Today's topic is concentration. So we've been talking about solutions, and concentration is what we use to measure the amount of stuff in a solution. So the definition of concentration is the measure of how much solute is dissolved in a given amount of solvent. And then there's three ways that we measure concentration. The first is using molarity, the second is mass percent, and the third is parts per million, or ppm. The chemist's favorite is definitely molarity. So let's look at molarity for a bit. Molarity is defined as the number of moles per liter of solution. So the equation is molarity equals moles divided by liter. So if we draw this little circle thing, this can help you guys do the calculation. So the purple M is molarity, the blue mole is obviously moles, and the green L is liter. Now, just like we did with the dimensional analysis, you're going to multiply across and you divide down using the circle. So, for example, if you're looking for molarity, you would draw your circle, fill it in, and then you'd cover up the M. And what's left is moles divided by liters. Then if you were looking for moles, say someone gave you molarity and liters and wanted you to find the number of moles, you would draw your circle again, fill it in, then you would cover up moles. And then this would give you molarity times liter would give you moles. Last, if you're looking for liters, you would draw your circle again, same thing, and then you would cover up liters. And then since you're going down, you're going to divide moles divided by molarity. So let's do an example of molarity. So what is the molarity of a solution made by dissolving 12.5 grams of sodium chloride in 0.45 liters of water? So what we're looking for is molarity. What they give us is 12.5 grams of NaCl and 0.45 liters of water. So molarity is our question mark. Moles are also a question mark, but we have the number of grams, so there's a way we can go from grams to moles. And then lastly, our liter is 0.45. So let's continue. Molarity example continued. So the first thing we want to do is we need to find the number of moles using a mass to mole conversion. We did those in the last unit. So the molar mass of sodium chloride is 58 grams per mole. They gave us 12.5 grams in the question. If you go back to the question, you can see that they gave us 12.5. We're going to put 58 grams down there because remember these two need to match. These units, grams, need to match. And then 1 mole goes up there because mole is what we're trying to find. So if you do that calculation, multiply across and divide down, you get 0.22 moles of NaCl. Step 2, we're going to use the circle to calculate. So again, if you recall, we are looking for molarity. So we have 0.22 moles and we have 0.45 liters filled into our circle. We're covering up molarity, and that gives us 0.22 divided by 0.45, which is 0.49 molar. And the unit is just a capital M. Okay, and that's it. That's the whole answer. Pretty simple stuff. The next one we're going to look at is mass percent. So the equation for mass percent is the mass of the solute, what you're dissolving, divided by the mass of the solution times 100, because it's a percent, so we multiply by 100. So when this mass of solution is the total mass of the solution, which means the mass of the solute plus the mass of the solvent. Mass of the solute, which what's being dissolved, over mass of the solution, which is the solute and the solvent. So let's do an example of mass percent. So question 8 on the last page of your packet asks, what is the mass of KCl in a 250 grams of 5% KCl solution? So what does it give you? It gives you 5.0% and it's asking for the mass of KCl. So it's asking for the mass of KCl, it gives you 250 grams, and it gives you 5%. So let's fill that into our equation. We have mass percent, we have the total mass of the solution, so let's fill it in. 5% equals the mass of KCl, which we're looking for, divided by 250 grams times 100. Now, if this were algebra and we're solving for x, our x would be the mass of KCl. So we're going to rearrange this equation. We're going to multiply by 250 and divide by 100. So it's going to look like this. Okay? So that's how you rearrange it, just to get the mass of KCl on one side of the equal sign. So once you do that calculation, you get 12.5 grams. That's how many grams of KCl were dissolved in that solution. So that's it for mass percent. The last one we're going to go through is ppm. ppm's pretty easy. So mass percent is really just parts per hundred. And then ppm is parts per million. So to get from ppm, to get to ppm, I should say, it's just the mass percent times 10,000. So for example, from the last problem, we had a 5% solution. If we wanted to find out how many parts per million that was, we would just take 5% times 10,000 equals 50,000. 50,000 ppm. Super easy. So that's it for concentration calculations.